Hi students, today I'm going to use IXL Practice to show you some problems with using Pythagorean Theorem to do some application problems and to use the converse to check to see if a triangle is indeed a right triangle. So let's go ahead and start it with the first one, which is using Pythagorean theorems to solve application problems. So here we have, so in order to do this, you're going to need a calculator, by the way. Um, here you have a someone is staining a glass window that is 21 centimeter by 28 centimeters. So this is the length and the width of a rectangle. So what we're going to do is we're going to, let me open my web paint here. I'm going to draw a rectangle here. So we have a rectangle and it's 21 by 28. So I'm going to go ahead and make the length 28 and the width 21. All right. It says to make the rectangular window pane, Brooke fuses together two triangles of colored glass. What is the perimeter of one triangle? So to do a triangle, what we're going to have to do is we're going to have to draw a line um, from one corner to the next corner, right? So that's the corner right there. And to find, now let me move this 28 out of the way. The 28 is actually down here. Oops, there you go. Let me this 28, delete that. And I'm going to put the 28 down here at the bottom so that you know you don't get confused with that. So what we're going to do is we're going to have to find how long this side is so that we can do the perimeter. Now, perimeter is adding all three sides up, right? Perimeter of one triangle. So I'm going to find the hypotenuse, essentially, right? So what you're going to do is you're going to do a squared plus b squared equals c squared. So you're going to do, and then you take the square root of that. So I'm going to show you a one step, and you get things right away, right? So you're going to turn your calculator on. Now, when you're using the Pythagorean theorem, in the end, you're always going to have to square root. So I'm going to go ahead and do the square root so that it's going to do all the calculations for me. So I'm going to do 21 square. Okay, so I do square root of 21 square plus 28 square. Okay, and that is going to get me the hypotenuse of that one triangle, right? So 35. Now, to find the perimeter, I will have to add 35 to 21 and to 28. Okay, to 28. So that would be the perimeter of the rectangle. So I'm going to go back to my, oh, what was the answer again? The answer was 84. So I will go back to this screen and I am going to type in 84 for my solution. Submit. Yeah, okay. Let me delete that. I'm going to draw a new shape here. Oh, it's also a rectangle, so I'm going to keep that rectangle. 6 by 8 meters, so I'm going to do 6 by 8. So I'm going to make the long side 6 and the short side 8. Okay. Oh, sorry. The long side 8 and the short side 6. Sorry. It doesn't really matter, but just to make it more believable. So that will be 8 and that will be 6. And then what are we doing again? Essentially, we're going to do this again. We're gonna follow Jackson's walk right here, right? So he's going to walk from here. He's starting right. He's starting right here. He's starting right here. This is where he's starting, right? This is where he's starting, and he start walking and walking and walking. And when he get to this corner, he's going to turn around to go back to where he started. So essentially, he's doing this. He's doing the right triangle walk, right? So he's going to walk that way. So again, we're going to find this 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 side, and then we're going to add his distance up. So right, this is 6. This is 8 meters and then 6 meters, and then we're going to add that side to it to get the whole distance that he walked. Okay, so again, get your calculator out, and you're going to do the square root of 8 square plus 6 square plus 6 square, and then enter. Now that 10 is only for the hypotenuse. You got to add 6 and 8 to it. Okay. And you're going to get 24. So I'm going to go back to my problem here and type in 24. Okay. 24 meters. Enter. Right? Yeah. Okay. All right. So here's another Pythagorean theorem. We're going to delete that rectangle. We don't need it anymore. Okay. All right. We're going to scroll down a little bit here. So here they're giving us the two legs, 9 and 12. When the two legs are given, either one of them can be A or B. I usually make the short leg A and the long leg B, just by my convention, right? The short leg is always going to be A, and then the long leg is always going to be B. It really doesn't matter, but that's my convention, just so that I can make up my mind really fast. So what we're going to do is we're going to do, because we're looking for the long side, which is the hypotenuse, we're going to be adding the squares of these and then take the square root. So same thing, pretty much the same thing. So calculator, we're going to do the square root of 9 square plus 12 square, plus 12 square. And that's going to give us the 15, which is C, right? That's how long C is. So I'm going to go over here and type in, what was the answer? 15. And then I will submit, and there's my answer. All right. My A, B, and C are still there. So this is A, and that's B. Again, we're going to do the same thing. I might have to skip around a little bit here, guys, because so square root, because these are repetitive, right? So I'm going to show you, skip around, show you a different type of problem. So 63 square plus 60 square. I'm going to jump level in just a second. Let's do this one problem and then we'll jump level. So 87 is our answer, right? So we go back to this box and we type in 87. Submit. Is it the same type of problem? Oh, great. This one is application. So I'm going to do one more application problem and then we'll jump level, okay? So Keith starts in the northwest corner of a swimming pool and swim to the southeast corner. Okay, so let me draw the swimming pool really quick. Assumingly it's a rectangular shape. And let's say he starts from the northwest corner. So northwest corner, if you know your west, south, and east and stuff like that, this is the northwest corner, right? And then he's going to swim to the southeast corner. So he's going to swim to the southeast corner. So he's going this way right here. He's swimming and swimming and swimming and swimming and swimming and swimming. And I'm going to assume he swims in a straight line, even though I didn't draw a straight line. But we're going to assume he swim in a straight line, right? So and then he swim along the width, which is 42 meters. Wow, that's a big pool. So 42 meters right here, 42. And then along the length, which is 40. So he's swimming back to where he began. So this one is 40. My rectangle doesn't represent this shape truly, because it should sort of be like almost a square. But anyway, 40, 42. So don't judge my picture. It's not drawn to scale. So what we're going to do is we're essentially looking for the hypotenuse again, right? I should have drawn that in red. But anyway, I'm going to be fancy a little bit and draw that line in red for you so you can see. Okay, so we're going to look for this. Okay, we're going to look for this. And when we find it, because they want us to find out how far he has swum, right? Or swum? Is that a word? Anyway, so once we find out how long this is, we can add the total. We can add all the distances up, and then that's going to give us the total. So we're doing the same thing again, okay? We're looking for C, and then we're going to add A, B, and C together to get the entire perimeter, okay? So second square root, 40 square plus 42 square. After this, I'm going to jump level, okay? 42 square, and then enter. That's going to give us C, right? That's just one side. And then I have to add A and B together. So 40 plus 42. That's going to give us the whole entire distance. So when you guys are doing these kind of problems, make sure you kind of have a visual in your head, and then draw a rectangle, and then do your drawing of a right triangle, and determine what you're looking for. All right. Anyway, 140 is the total distance that he has swum. 140 meters. Ah, that's a lot. 140. I don't know if I can swim that much or that long. 140 meters. Enter. Yay. Okay. All right. I'm gonna jump level. Let me clear out all of this. There you go. I'm gonna jump level. Let's see what kind of problem we get. We are in the jump level again. It's the same thing. All right, 81. Well, we'll do an 81 problem. Maybe we'll jump level again. It's going to get us to the challenge zone. All right, we're in the challenge zone. All right, the challenge zone has. I'm hoping kind of picture. So let's try this one. Okay, let's look at this problem. Uh, from her home, Sophie will have walked due north to get to her friend Cindy's house. So I'm gonna say. I'm going to say right here is Sophie's house. I'm going to call that S, right? And then she's going to go north to get to her friend Cindy's house. And then from her house, from Sophie's house, she's going to have to go east to get to Henson's house. So Henson's house is over here. I'm going to zoom somewhere there, okay? And so north and then east, right? So this is essentially what we have is a right triangle. So I'm going to draw a right triangle for you guys. Draw a right triangle here. And then from there, I'm going to go down here. And then from there, I'm going to go back over here. So that's our right triangle. Okay, so now I'm going to put in some measurement. Okay, it says right here it's 2 miles from Sophie's house to Henson's house. So right here is 2 miles. I'm going to put a 2 there. And then it says 3 miles from Cindy's house to Henson's house. So essentially, they're telling you that the hypotenuse is 3. So what are we looking for? How far is from Sophie's to Cindy's? So we're looking for the distance of the leg of this right triangles, right? So we're looking for the distance from Sophie's to Cindy's house. So now, guys, every time you're looking for the leg, which is the shorter piece of the right triangle, you have to do subtraction, okay? So Pythagorean Theorem is the same thing, square root, okay, of a c square, which is the longer side, so 3 square. And then now we're going to subtract, so minus 2 square. Okay, and guys, it is not 1 square, so don't even assume that. Okay, enter. We get 2.23606, blah, blah, blah. It says, if necessary, round to the nearest tenth. Nearest tenth is 1 decimal place. So in this case, we're going to say it's 2.2. We're going to drop the 3 because it's not 5, right? So go back to our screen. We're going to put 2.2 miles in there. Okay, 2.2. Oops. This problem was different than the ones we did before because we have to end up subtracting instead of adding, right? Submit. All right. So guys, that's pretty much the Pythagorean theorem. So what I'm going to do next is I'm going to first, let me delete this. We're going to get to do the converse, okay? The converse is actually what you're new to in geometry. This Pythagorean theorem business, you should have already learned it in middle school. So go to the converse. So we use the converse to verify to see if a triangle is indeed a right triangle, right? So in this problem, they're giving us a triangle with side lengths 9, 12, and 15. So as we look at this, we see that the longest segment here is 15, right? The longest segment is 15. So, oops, what am I doing? I should underline that. The longest segment is 15. So that is your C. So what you're going to do is you're just going to do your A squared plus B squared, right? So you're going to do 9 square and do 9 square. And then you're going to do plus 12 square, right? So 9 square plus 12 square. And then we're going to get an answer, right? We're going to get an answer. And our answer is 225. So you go back over here and you say, okay, it's 225. Right? Let me test the other guy. Let me test 15 square. If I do 15 square and it's also 225, then I know is equal, right? 225 equals 225. So if a squared plus b squared equals to c squared, then we say it is a right triangle. So I'm going to say yes. All right, so that's pretty much it. You're using the Pythagorean theorem converse. The converse says if a squared plus b squared equals to c squared, then it is a right triangle. Okay, so again, we're going to do this. Use your calculator. Our calculator is going to be really fast. So 5 squared plus 10 squared, okay, and that's going to give us 125, okay, and then we'll do 11 square. Now 11 square is only 121, okay, so if you can do this math in your head, you don't need a calculator. 125 and 121 obviously not equal to each other, so we're going to say no in this case. No. Okay, all right. Okay, next one. 8, 15, and 18. 18 is the longest, so we're going to do 8 square. Now, you guys be careful. Sometimes they don't give these in the same order from smallest to largest. Sometimes they throw the longest side in the middle just to trick you, right? And then you think that the longest side is actually the shorter side. So, and then you mess up. So a squared plus b squared is 289. You do 18 square. Oops, that's too big. Oops, sorry. Clear. 18 square, not 118. 18 square equals 324. So it's too big, right? It's too big. It's bigger. So they're not equal. So I'm gonna say no. Later on, we're gonna learn. Okay, if it is not a right triangle, then what kind is it? Is it obtuse? Is it accuse? Is it, I mean. So anyway, submit. Yeah. Okay. Jump level, maybe. Jump level. All right, so this one we have 38, 83, and 88. Okay, so, well, 38 and 83 are the shorter ones, right? So we're going to do 38 square plus 88 square. Ooh, these are going to be some big numbers. 88 square equals 9,000 something. And then we're going to do 88 squared to see what we get. Okay, they're not equal, so no, it's not a right triangle. Okay. Ta-da! Okay, 10, 24, 26. So again, repetitive. 10 square plus 24 squared, and then equal 6 something, 676. 26 square. Ta-da! 676. Yeah, they're equal. Okay, so yes, submit. Okay. All right, very good. Well, guys, that's pretty much it. Okay, now be careful here. Notice how they put 15 feet like way up here, which is the longest side, right? So you always have to look for that. When they're giving you 3 segment, you have to look for that. You have to look for which is the longest segment. So don't fall for their trick. So we're still going to do the 2 shorter ones square, right? Add together 11 squared plus 13 squared. Okay, 13 squared. And then equal 290. Well, I know 15 square is not, it's less than that, right? So 15 square. So they're not, these links won't make a right triangle. So no, submit. All right, well, I'm going to stop here. I hope that was helpful. You guys, and it's easy. Get a calculator, get your work done. Thanks for watching, and I will see you in the next video. Bye-bye.